All right, this is lesson 61. We are converting exponential equations to logarithmic equations, okay? This is a new word for us, logarithmic. Some people say logarithmic. Either way, whatever. Or we can just shorten it to log or logs, okay? So these are just kind of a new type of equation. They're directly related to exponential equations, and we will see how this looks, okay? So we're going to convert between exponential and logarithmic equations. It's going to be super fast, super easy, okay? So here are the steps. First, we're going to identify the parts. These should say 2 and 3. I'm not sure why it formatted that weird. So we are going to identify the parts of the exponential equation. So we have some base raised to an exponent equal to a number. When we rewrite the exponential equation as a logarithmic equation, this is where those numbers go, okay? So the base becomes now what we call the base of the log. So we say log base and then whatever number equals some number, and that it comes from the exponent and the number above. Okay, so for example, say we had, say that I had 2 to the third equals 8 here. I could rewrite that as a log by saying log base 2 of 8 equals 3. Okay, so just rewriting using this form. Okay, this as a guide. Right, and then I will use the reverse order when necessary. So sometimes it'll give you something that looks like a log and it'll say write this as an exponential equation. So you'll rewrite it that way. Okay. Alright, so for this first example, it wants us to rewrite the equations in logarithmic form. So I'm going to just write down what each piece is here. So the base is 2. The base is 10. The exponent is 2, and the other number is 100. So I'm going to use the format guide, right, to rewrite this as a logarithmic in logarithmic form. So that's the same as saying log base 10 of 100 equals 2. Okay, and then moving on to number 2, I have the base is 20. The exponent is a, which is fine. We're totally allowed to have a variable in any one of these spots. It's not really a big deal. We're just following the kind of formula here, right? So then the number is 183. Okay, so I would say log base 20 of 183 equals a. Alright, and moving on, a couple more examples here. Again, I'm just writing down each piece. So the base here would be 2. The exponent would be 5. And the other number then is 32. Okay, so now I rewrite the equation in logarithmic form using that kind of basic layout. So I'll have log base 2 of 32 equals 5. Okay, then for number 4 in class, I had the students do this on their own. So they were to get log base 125 of 5 equals 1/3. Alright, then moving on, our last 2 examples now are going to have us go the other way. So it's giving us the logarithmic form, and it wants us to rewrite the equations in exponential form now. So here we have the base for number 5. The base is 2, right? And then the number that I would call the exponent is on the other side of the equal sign, right? That's where it ends up. So my exponent, I would say, is 3. And the other number is 8. Which means when I rewrite this, I should have 2 to the third power equals 8. And I can check that mentally that makes sense, right? Because 2 times 2 is 4, times 2 is 8. Alright, then on number 6, I'm going to rewrite this as an in exponential form. So my base is just x. The exponent is what's on the other side of the equal sign, so that's y. And then the other number now is on the other side of the equal sign, so I have x to the y equals 75 over 176. That's it. So this is a short concept, but it's something that's really helpful. Again, when we did the inverse lesson, you might remember that we kind of got stuck when we had something with y in the exponent like this because we couldn't pull it down. So you can see how switching it into logarithmic form can be helpful. So we'll be doing that in future lessons. All right, that's all for today's lesson. Thanks.